Okay, this is example 3. Okay, again, they want our answers in a certain interval. They don't want infinitely many answers like the first example, so we're going to have to test out values of n when we get to the end of this question. All right, so the sine of some value equals 1/2. So again, sine is like y, and the answer here is positive. So the first thing I think of is, where would y be positive, in what quadrants? Well, that would be quadrants 1 and 2. So I like to just draw a quick little sketch of a triangle, very generic, in quadrant 1 and quadrant 2. So the y value would be my vertical side. So if I label each of these vertical sides here and here 1/2, what would these angles be? And again, we're talking radians, not degrees, but if your first answer was in degrees, that's fine. You can always just change it to radians. In degrees, this would be 30 degrees. In radians, these would be reference angles of pi over 6, because that's the same as 30 degrees. So I basically have two answers. One is this rotation up to here, which is pi over 6, and then the other one goes from here all the way over to there, which is pi over 6 away from 6 pi over 6, which is pi right here, is 6 pi over 6. But if I'm 1 pi over 6 short of that, then this position right here would have to be 5 pi over 6. So my two positions are pi over 6 and 5 pi over 6. Now remember, those are my original positions. If I want more positions, if I want to rotate around again and stop in that same spot, I'd have to add 2 pi and then n being however many extra rotations. 1 rotation, 2 rotation, 3 rotations, that's n. Same thing, oops, sorry. I meant here, but anyway. Same thing on the other side. If I want to add additional rotations, I'm going to get the same answer if I stop in that same spot, simply by adding 2 pi, and n being the number of additional rotations that get me there. Okay, so what is the angle that equals this position and this position? Well, here you can see the angle right here is x over 3. So that is the angle that equals that from the original expression. So now basically our final trek here is to figure out what x is, now that I've established my two equations. So in order to get x by itself, this time I'm going to have to multiply by 3 on each part, on each term, in order to just get the x by itself. So here I get x equals 3 pi over 6 is pi over 2, and 3 times 2 is 6. Here I get x equals, this would be 15 pi over 6, and 15 pi over 6 reduces to 5 pi over 2. Plus 6 pi n. Okay, so now we have to figure out what n, how many rotations of n would give us answers that would still get us between 0 and 2 pi. So 2 pi being the largest possible answer that we could have. So if we go over that, it's too big. So I'm going to first start with this answer. If n equals 0, then x equals pi over 2, obviously, because this would be 0. If n equals 1, x would equal pi over 2 plus 6 pi, right? Because 6 pi times n would be 6 pi. And obviously 6 pi plus pi over 2 would be bigger than 2 pi. So that is out. That's a no. That's too big. So I'll just say too big. So that's not an answer. So anything larger than n equals 1, n equals 0 is an answer that's outside the interval of our answers, so that we can't give. All right, so that's the only answer that comes from this statement. How about this one over here? If n equals 0 over here, we get x equals 5 pi over 2. Now, is that within the margin here between 0 and 2 pi? No. 5 pi over 2 is bigger than 4 pi over 2. Because 4 pi over 2 is 2 pi. So already the first answer doesn't work. So we're going to have to say that that's too big and that there are no answers that come from this position on the circle. So there's really only one answer, x equals pi over 2.